This is numbers 29 through 31 on the study guide. On numbers 29 and 30, our goal is to justify Esperanza's conclusion about the theorems that she gives here. We're going to use this picture right here. It says Esperanza knows that the basketball pole intersects the court right here to form a linear pair of angles that are congruent. So we know that this linear pair angle and this linear pair angle are congruent. And so she concludes that the pole and the court are perpendicular. Well, why is she allowed to say that? Well, we learned a theorem yesterday that said if you have two congruent linear pair angles, so two angles that are a linear pair and they're congruent, what that means is that you have perpendicular lines, and that's the theorem that we learned yesterday in class. Esperanza knows that the hoop and the court are both perpendicular to the pole. She concludes that the hoop and the court are parallel to each other. We also learned a theorem that said if we had two coplanar lines that are perpendicular to the same line, this means that the lines are parallel. So that's the theorem we learned as well. On number 31, we're going to complete a proof. We're told that M here is
with the Smiling Citizens and Dance Team, as well as the Science Art Society, please report to the stadium. Again,
line M and line N are perpendicular.
Please report to the stadium. Thank you.
So line M and line N are perpendicular, which is part of my given. And then what do we have here? Well, if they're perpendicular, then we're going to go ahead and say that we get certain kind of angles, because perpendicular lines form angles. So what does that allow me to say? Well, that allows me to say that the measure of angle 1 is going to be 90 degrees, and it allows me to say that the measure of angle 2 is going to be 90 degrees. Why? Because perpendicular lines form 4 right angles, and right angles are 90 degrees. So this is our definition of a perpendicular. If they are congruent here, in other words, their measures are the same, we can say that they're congruent. The reason why is definition of congruent angles. You could also argue that this one would be substitution, and then it would be definition of congruent angles. You could say that this is a transitive property, and then congruent angles. You could even have backed up this way and said that you had 4 right angles, and then you could have said that the angles are congruent because all right angles are congruent. So there's a few things that you could take here. And then, therefore, if the angles are congruent here, what does that mean? It means that if we took these two angles and we added their measure together, that's the addition property of equality. And what that allows us to say is that angle 1 and angle 2 are a linear pair of congruent angles.